Okay, also after your midterm, I'm going to send out a survey asking for some feedback, because otherwise we always get this feedback at the end of the term. And of course, it's too late for redemption then. So I'll send around sort of a TA evaluation so that maybe I can veer onto course before the end of the quarter. Okay, so looks like people have the worksheet open. Great. Okay, so you have a midterm tomorrow, and the things that you have to know for this midterm. One is vectors and basic vector arithmetic, okay? You should be extremely comfortable adding vectors, taking their dot products, taking their cross products, computing their magnitude. You should know how the magnitude is related to the dot product. You should know what it means geometrically to take a cross product. You should know the cosine formula for the dot product. You should basically just be very comfortable with everything that we've talked about in section the last few weeks. Okay, and even though the geometry, I doubt he's going to ask you to draw a picture or anything, I think it's very important to understand it, because if he asks you to come up with certain planes that contain certain vectors, then you're going to need to be comfortable understanding how the cross product relates to the normal vector of a plane, right? Like if you have two vectors on the plane and you take the cross product, you get the normal vector to the plane. So this is a very important fact. And you should also, what we're going to focus on today, because the professor told me to, and I don't think you've covered it as much yet, but it is fair game for your midterm, is parameterization. So we're going to talk about how, given some surface or a description of a surface, you can come up with parameterizations. And then the last thing is Cartesian equations. And if you don't remember what this means, it just means you have some surface or a description of a surface, and you want to write down an equation, a polynomial equation, such that the zeros of the polynomial equation cut out the surface in three-dimensional space, okay? Great. So let's begin with the problems. So start with problem 1. And this illustrates a very important principle of the dot product, which hopefully you understand. But if not, you'll understand it after this problem. So F's in the chat when you solve it, or C's in the chat if you're confused. Okay, so we're getting, oh wait, I don't, these F's, are they from, sorry, put F's in the chat again if you got it, because I'm not sure which F's were. I got the worksheet open versus I solved it. All right, great. So it looks like a pretty good number of people have got it this time. Any C's? It's okay if you have C's, but can DM them to me. What happened to the other 9 people, or 7 people rather? Okay. Yeah, and to the one brave person who put a C in the public chat, other people DM'd me C's, so don't feel like you're the only one. You're just the only one brave enough to put it in the chat. Okay, so let's go over it. The idea here is one of the principles that you should be comfortable with on your midterm is knowing how the dot product relates to the magnitude, right? So in this case, remember that, let me choose a different variable. Let's say alpha. So alpha, alpha dot alpha is equal to alpha magnitude squared, okay? And so in this case, what we want to do is we want to take v plus w dot v plus w and subtract off v minus w dot v minus w, okay? And this gives you, remember the dot product's linear, so this gives us v dot v plus v dot w plus w dot v plus w dot w minus v dot v and minus v dot w plus, or sorry, no, minus w dot v. Here I'm just expanding this out, and then plus w dot w. So is there any confusion there? Hopefully there's no magic, but is anyone confused?
I have a quick question.
Yeah, go for it.
This is kind of a dumb question, but the second line you wrote, if that was just like what I put, like would that give me any partial credit on the test because I didn't do all the expanding stuff?
You know, that's a good question. It's certainly not the answer that I was looking for, but I guess if you wanted to troll, you could definitely go and argue that this is a valid answer. But I think to be safe, if you can, you should try and simplify. And
Okay. All right.
the only dumb question is the thing that you're confused about but don't ask about, because then you remain confused. Okay, so then these guys cancel out, these guys cancel out, and we're left with v dot w plus w dot v minus 2 v dot w. Okay, here I'm just using the fact that it's symmetric again. So it should be minus 2 v dot w. So that gives you 2 v dot w plus 2 v dot w, which is 4 v dot w. Okay, so any issues with that? Why did I take out a negative? Oh, so I didn't. Here, remember we were subtracting here. Someone asked me in the chat, why did I take out a negative? So I didn't take out any negative. I had a negative out front, and then I expanded what was in the parentheses, and that gave me this. And then I just canceled these because I have a negative here, a positive here, and then a negative in front of this, positive here, and a negative in front of this. And so then I just subtracted these two and got a minus 2v dot w multiplied by minus 1, which gave me 2v dot w, and then added these 2v dot w's. Okay, great. So that gives you 4v dot w. Hopefully there's no sorcery here. Okay, so let's move on to problem 2. And again, F's or C's in the chat when you solve it. Or get confused. Okay, so I have one C in the DM. Don't give up quite yet. Oh, and many C's outside the DM. Oh no, another C in the DM and one C, one brave C in the public chat. Great, so it looks like everyone's confused. I'm gonna wait for a few more C's and then try and rescue you. Oh, good, another C. All right, so I think, yeah, I think everyone's universally confused. So let's see what's going on. All right, so the question here was you have these two equations, which are x equals cosine 3 cosine t, and y is equal to 2 sine t. Okay, and so in order to create a Cartesian equation, remember we want to find something in terms of x and y, right? And so in order to do that, we got to eliminate the t. And the way we do that is, so we have to come up with a relation that these two will satisfy that doesn't involve t, despite having t in each of the individual functions. And so the natural choice would be x over 3 is equal to cosine t, and y over 2 is equal to sine t. And this gives us x over 3 squared plus y over 2 squared is equal to cosine squared t plus sine squared t. And then we can rewrite this as x squared over 9 plus y squared over 4 is equal to 1. Okay, so that's your Cartesian equation. And if you're curious what it looks like, it's an ellipse. So you have x goes from 3 to minus 3, and y goes from 2 to minus 2. And that gives us this guy. Okay. So let's keep going. So now I want you to find a parameterization for the line between 1, 2, 3, and a point on the plane 4x plus 3y plus 2z closest to 1, 2, 3. This is the second part of the problem. And I guess it might not be immediately clear how you do this. So let me give you a little bit of a hint. If you have some sort of plane like this, and you have some point that lies above the plane, then let's draw a triangle. Say that this is the normal vector to the plane at this point, extended up to this point here, which we're going to call, I think, 1, 2, 3. Okay, And so then choose any other point on the plane, say this one. Then we can draw a right triangle, right? But the question is, what is the shortest length to this point, 1, 2, 3? So that's my hint. And let's get F's or C's in the chat when you, oh, sorry, that wasn't supposed to be a direct message. There. So when I found a Cartesian equation above, how did I know to square and add the x and y terms together? So that's a fair question. How did I know? There's no surefire way to do this type of conversion. You just, I guess you just have to see it, right? So in this case, I saw that I had a cosine and a sine. And I knew that one way to eliminate a t is to turn a cosine and a sine into a 1. And so I just did that and hoped things would work out. And they did. But yeah, I'm sorry, I don't really have something more satisfying than that. Great, so I have another C in the direct messages. Also, if you're just seeing on all of these problems, that's okay. I think I generally write the problems intending them to be a bit harder than the midterm. So if you looked at the practice midterm, in my opinion, it was much easier than these problems. Great, so I have a bunch of C's. Does anyone think that they're making significant progress on this, or should we go over it? Okay, so I have no one claims to be making progress. So let's just go over it. Right, so the idea here, what I was trying to get you to do here was notice that if you can draw a right triangle like this on the plane that goes up to this point, then I was hoping that someone would notice that this leg of the right triangle is the shortest distance. The reason being that the hypotenuse is always larger than either of the two legs. And so if you choose any point that's not the one that's directly under our point 1, 2, 3, then you're going to end up following the hypotenuse of this right triangle up to that point, rather than just one of the legs of the triangle. Does that make sense? So F's in the chat if that insight made sense. Great. And actually, the first time I saw this type of problem, I did it a very stupid way, which was, well, it's not very stupid, but I did it by using calculus to take a derivative and minimize the distance using a three-dimensional distance function rather than having the geometric insight. But the geometric insight is much easier. So then what do we have to do? The next step is going to be, what is the normal vector to the plane? So the plane is 4x plus 3y plus 2z is equal to 0. And so can someone tell me what the normal vector will be? Yeah, 4, 3, 2. Okay. So now we know that this line here is going to be 4, 3, 2 t plus something. Okay. So we don't know what this point is, but we do know one point on this line, right? Which is 1, 2, 3. Does that make sense to everyone? Because we're starting at 1, 2, 3, and then we're following an orthogonal line to the plane until we hit the plane. So we don't know what the value of t is going to be, but we can solve for it, right? Does that make sense? Great. Can someone ask a question if it doesn't make sense? Okay, 3 people say it makes sense and 10 people are silent. So, okay. I guess the more common variant of this problem will ask you to also compute what the point is on the plane, okay? But in order to do that, it's not very hard. All you have to do is take this equation and plug it into the variables for the plane and then solve for t. Yeah? Great. So since people are having some difficulty with parameterizations, which one do I want to do next? Yeah, let's do 3a. Oh, and also when I recorded last section, I remember I got a bit confused on the last problem, but I solved it and just added an addendum to the recording about, oh, hope that bird's okay. Added an addendum to the recording about how to do it. Okay, so F's in the chat when you get 3a. Right, so I have neither F's nor C's. Okay, 2 C's. Oh, 1 F, great, great. Someone says it's embarrassing, but see, it's not really embarrassing. I think it's possible I wrote questions that were a little too ambitious this week. I guess generally in section, I just can't see the point of me watching people do a bunch of computations because I guess there are many resources for that on the internet. Another C. But don't worry, someone else will be writing the remaining section worksheets. Okay, let's go over it. So the idea here is you have a sphere in three-dimensional space. And we just want the level set of where x equals 4, okay? So we want all the points where x is equal to 4. And our equation for the sphere is x minus 3 squared plus y minus 2 squared plus z minus 1 squared is equal to 4. And so what I was hoping you would do is take x is equal to 4 and plug it into this, okay? So that would give you 4 minus 3 squared plus y minus 2 squared plus z minus 1 squared is equal to 4, okay? And so then we get 1 plus y minus 2 squared plus z minus 1 squared is equal to 4. And let's just get rid of this now so I don't have to rewrite it. And so then you get y minus 2 squared z minus 1 squared is equal to 3, okay? And generally speaking, whenever you do this type of thing, where you're parameterizing a circle, you're going to want to use sine and cosine somehow, okay? So probably you know that if you have a circle at the origin, your equations are going to be sine t and cosine t, and you'll put a √3 on them because the radius is √3, okay? But in this case, what we have is we have a circle that is centered around the point 2, 1, okay? So 2, 1. And what does that mean? It just means that we have to shift these coordinates a little bit, okay? And the way we shift them is we take √3 sine x plus 2 and √3 cosine x plus 1, because this is going to shift these two coordinates over and up, okay? And so as a sanity check, let's plug it back in. Oh, and of course, x is going to be equal to 4, okay? Because we just declare x to be 4 because we want the circle, I guess x is 4 is here. We want this circle on which x is always 4, okay? And so let's plug it back in. We get 4 minus 3 squared plus √3 sine x plus 2 minus 2 squared plus √3 cosine x plus 1 minus 1 squared. And let's see what that's equal to. So that's 1 plus, is equal to 4, right? So then we get 1 plus, so these guys cancel and we get 3 sine squared x. I should be using t's. That's a mistake. I switched somewhere. We get 3 sine squared t plus 3 cosine squared t is equal to 4. And then we get 4 is equal to 4, right? So we know that this parameterization is valid. Are people happy with that, or do people have questions? I hear crickets. Okay, I guess everyone understands perfectly then. Great, how did I get 4 on the left? So sine squared plus cosine squared is equal to 1. So I get 3 times sine squared t plus cosine squared t. And that's equal to 3 because that's just 1. And then I add 1 and that gives me a 4. Okay, no further questions? Great. Let's go on to do problem 4. This one is actually, how do I choose which should have been sine and cosine? Yeah, at the end thanks for the questions. So sine and cosine, it doesn't matter. If I switch which one was which, I just would have gone around the circle in, starting from a different point. So if I'd switched which one was sine and which one was cosine, I just would have started from this point instead of this point on the circle. Yeah, you can reverse it. So if you choose the parameterization where this is, wait a sec, this one is y, and this one is z. Let me think for a sec. I made it sine and cosine. So y should start out at t equals 0, y should be 0. So that means that, okay, so with this parameterization, I'd start here, okay? And I'd go around the circle. With the other parameterization, where you make cosine, where you flip cosine and sine, you would just start here and go around the circle, okay? And there's more you can do. Like you can even make one of them, no, never mind, you can't make a negative. So, but you could instead take like cosine of minus t and sine of minus t, and then you would just go around the circle in the reverse direction. Okay. And then at the end, yes, I was checking my work. And trying to illustrate to you that these equations were reasonable. But hopefully the insights from where they came from make sense. I think that this subject is very geometric. So even though geometry isn't strictly necessary, it is extremely helpful to have a good spatial sense here. Let's do problem 4. Problem 4 is basically the same as the problem that I messed up at the end of section last time. So let's see if we can solve it now. And I actually made it slightly easier. So we're finding where two planes, yes, intersect, right? So you're finding the intersection. Yes, that's correct to the person who DM'd me. So remember F's or C's. Great, I'm happy to see some F's. But I'd also be happy to see C's. All right, so we're running down the clock. Let's go over it. Okay, so we want to find the intersection of the planes x plus 2y plus 3z equals 0 and 4x plus y plus z equals 0. Okay, so let's draw a picture. There's plane 1, and there is plane 2, and they don't intersect at a right angle. This isn't a right angle or anything necessarily. And so then we have their normal vectors, which let's just draw them from this point, look like maybe that, and maybe that, or something. And so we know that this line here is going to be the cross product of those two, at least the direction. So the cross product is 1, 2, 3, 4, 1, 2, 4, 1, 1. We want to take the cross product. And this gives us I hat 2 minus 3 minus j hat 1 minus 12 plus k hat 1 minus 8. Okay, and that gives us minus I hat plus 11 j hat plus minus 7 k hat. Okay, and so then we know that minus 1, 11, minus 7, if I didn't make a mistake, is the direction of the curve of the line. And we have more good news, which is we need a point on the intersection, right? Because this just gives us the direction. And now we also want a point on the intersection. And a point on that intersection can just be found by inspection. You can plug in 0, 0, 0 into these two equations and see that it satisfies both of them, right? And so then plus the origin is your solution, okay? So any questions? Right. Oh, 3B. I will post solutions probably later today, but I can't promise. But what I can say is probably this is too hard for your midterm, the challenge problem. Yes, Stephen, there is a way to get it to get a point on both planes, even if it weren't 0, 0, 0, 0. And that will be in the video that I upload. I just managed, while I was waiting for people to think, I was finding my old Zoom videos. So I'll upload them right now, and you can go watch the addendum to last lecture. And then if it doesn't make sense, you can send me an email, okay? Great. Okay, so I'll post a link to my website later today, along with the Zoom recordings, which will be linked from that website to YouTube. And just let me know if there are any problems. So good luck on your midterm. Remember, my office hours are Tuesdays at 7. Not very many people show up. And see you next week. Thanks for coming.